Hello, this is Cheryl Bullock, Dr. B. I'm an instructor for your course, and along with Heather Miller, who is the research lead for the research courses here at Walden in the EDD program, we've come up with a brief video. We want to talk about hypothesis testing with you. And I want to start with an example. A criminal trial is an example of hypothesis testing outside the realm of statistics. But think of it like this. The null hypothesis, which is HO, is that the defendant's innocent. The alternative hypothesis, H1, is that the defendant is guilty. So in the language of statistics, if you convicted the defendant, you would be rejecting the null hypothesis that and doing that in favor of the alternative hypothesis. That is, the jury is saying there just isn't enough evidence to conclude that the defendant's guilty, not enough evidence to support the alternative hypothesis. But if the jury acquits, it's stating that there is not enough evidence to support the alternative evidence. Notice that the jury is not saying that the defendant is innocent, only that there is not enough evidence to support the alternative hypothesis. And that's why we never say that we accept the null hypothesis. Along with hypothesis testing, a very critical issue to understand is type 1 and type 2 errors. A type 1 error occurs when you reject a true null hypothesis. So in our example, if you convicted an innocent person, you would commit a type 1 error. And in our example, if you let a guilty defendant go free, you would commit a type 2 error, because that's when we don't reject a false null hypothesis that really should have been rejected. So there are four possible outcomes. And you can see that a type 1 is when the null hypothesis is true, but we reject it. And a type 2 is when the null hypothesis is false, but we don't reject it. So summing it up, a type 1 error occurs if one rejects the null hypothesis when it's true. A type 2 error occurs if one does not reject the null hypothesis when it's false. And in our example, hypothesis testing likened to a jury trial, there are four possible outcomes. Defendant's guilty, innocent. The jury can convict or acquit. So here, a type 1 error is that they're innocent, but they get convicted. A type 2 error is they're not innocent and they're let go. In hypothesis testing, the probability of a type 1 error is denoted by the alpha letter. And the probability of a type 2 error is denoted by the beta. And this will be important in another slide. But the two probabilities are inversely related. So in other words, the higher the alpha or type 1 probability error is, then the lower the type 2 or beta probability is. And the reverse is also true. So in our example, type 1 errors are pretty serious. We don't like to send people to jail if they're innocent. So we arrange to make the alpha very small, maybe 0.001 if this were actually a research able statistic. But we arrange but how we do it outside the realm of statistics to make our alpha small is we say, the judge tells you, as a jurist, that it's really bad to send an innocent person to jail. So you want to make sure that when you're making this decision, your evidence is beyond a reasonable doubt. Well, now let's move into the realm of statistics. And there, what you have in educational research is not quite as serious of a situation as sending someone to jail who's innocent, but it can be still important. We're often dealing with educational programs, different interventions that might be used on students. So it's not just something we're going to toss away lightly. We don't want our alpha to be huge. but traditionally we use an alpha of 0.05. So if you think about it like this, the p-value is the calculated probability. Alpha is the criterion used to determine statistical significance. Educational research typically uses an alpha of 0.05. And so putting that all together, let's say you ran your statistics and your p-value that SPSS puts out and tells you and lets you know is 0.03. And already before you run your statistics, and this is very important that this is done prior to running statistics, you had determined, well, I'm comfortable with a 0.05 alpha level. Then, in this case, the result's statistically significant, or you would reject the null hypothesis. And remember, typically educational research, that's just our most common one. You might see 0.01, you might see 0.10, but most commonly in educational research, you see 0.05. And that's really all that I have to say. I know this is one of those slippery eel concepts where it's not exactly easy to totally grasp, but I think it's important for graduate students to understand this. Thanks.